Right, okay, year 12, here we go with the integration video. So let's have a little look at this one. So here we go. So the curve has gradient function that, find the general equations. This is just using the fundamental theorem of calculus. The differentiation and integration are inverse functions, and so all we've got to do is integrate this. So this is simply going to mean that y is going to be, we've got so our 3 there, our x will increase the power by 1 to 5, and we're dividing by that. So 3/5 x to the 5 for our second term. We've still got the 5 there, but x will raise to a power of 2, and that will then be over 2. And then we've got the 2 will just become 2x, and then we've got our plus c, our constant of integration. Don't forget that. Okay, for b, we're now told that our curve passes through the point 12 to 12. So given what we've just got, in fact it might help us to bring that over. Okay, open. So given what we just got, which is there, and now we just need to substitute in the values that we got here, the 2 12. So 12 would be equal to 3/5, and then 2 to the power of 5 minus 5 over 2, 2 squared plus 2 times 2 plus c. Now if you put all of this stuff into your calculator here, that will give you 13.2, and so c comes out to be minus 1.2. So we've then got that y is equal to 3/5 x to the power of 5 minus 5 over 2x squared plus 2x minus 6 over 5. Okay, moving that on to question 2 now. So express this in this form. So you're going to have to expect that your initial thing that you get in a question, your initial expression, is probably going to require a little bit of tidying up. And in this case we've got to divide by x to the power of 5. So that's obviously x to the power of 1, and 1 subtract 5 is minus 4. So that will be 2x to the power of minus 4. And then we're just going to have this minus and the 7, that's not going to be affected. Then 2 subtract 5 is going to give us x to the minus 3. It's just one mark for doing that, because you were told to do it, but you're going to expect to do it even if you're not told. Now we've got to integrate that, and we've got, now I have to bring this back over again, aren't I, like I did previously. Okay, alright, so now we're going to integrate this. So pen, and so we're going to have the integral, a general integral of 2 to the x, 2x to the minus 4 minus 7x to the minus 3. Stick all that in brackets to show it in the whole thing, dx. And so all that's going to be, so increase the power by 1, so it's going to give us minus 2/3 x to the minus 3, and then plus, because we're going to divide by minus 2 now, plus 7 over 2 x to the minus 2, and don't forget our plus c because it's an indefinite integral. Okay, pushing on to question 3 now. We've now got a definite integral. It says you must show your work, and so obviously your calculator can do this, and in fact we'll just verify our answer on the calculator when we're done. Because it says you must show your working, that means you've got to do it the full-on old-fashioned way. So let's put it in square brackets to show that we're going to have something we're going to have to evaluate. And we integrate 6x squared to raise the power by 1, divide by the new power. That becomes 2x cubed, and the x, the minus x here, root x here, if we just tidy up what we would have had originally, that's going to be our integral from 1 to 4 of 6x squared minus x to the half dx. So we're going to now, this is going to become minus 2/3 x to the 3 over 2, which then we evaluate between 1 and 4. So our power of x was a half, we increase it by 1 to 3 over 2. Dividing by 3 over 2 is the same as multiplying by 2 over 3. now we've got to substitute in our limits, so we'll put in our upper limit first, so 2. I'm just going to just put each bit in brackets, just it makes it super clear what's going on. Right, now that's as far as we need to really go in terms of showing your working. You're not required to show that you can do calculations with powers and numbers and stuff. That's very much been already assessed in GCSE, and so you can literally just go from having got that substitution to the answer, which is 364 over 3. You can just punch all of this into your calculator if you in order to do that. Right, let's just show how the calculator would have done this, though. You can't do this with a question because you had this. You must show your working, but let's go through this stuff anyway. So it'll be after calculus, which is going to be in calculations, and we want to do an integral, and the integration symbol is on the calculator somewhere, and as soon as I see it I'm going to think, well, why, there it is. Okay, so we are going to want to integrate, so our limits, let's just use the arrow, move around a little bit. So we're going to want to integrate this thing, so we've got 6, x is going to be there, x squared minus root x, and we need to put our limits in, so just tapping the right arrow will bring us to our lower limit, which is going to be 1. Tap the right arrow again, upper limit is going to be 4, and there we go, 364 over 3. So do use the calculator to check, even though we were told that we couldn't use it for the answer. Okay, question 4 now. Again, this is another definite integral, but there's a slight twist on this one, and again it's to fully justify your answer, so I'm afraid you cannot just use the calculator. So here we go. So it's going to be the integral from -1 to 2 of x squared minus 7 with respect to x, and then when we integrate that, that's clearly going to be x cubed over 3 minus 7x, and we're going from -1 to 2. And now let's just show that in two separate brackets what we've got going on here. So we'll put our upper limit in as 2, so 2 cubed over 3 minus 7 times 2, and then we can subtract away what we get for the lower limit, so that's going to give us -1 cubed over 3 minus 7 times -1, and at that point we can just pop that into the calculator, and we're going to get out our answer of -18, and that must mean that the area, it's got to be 18. You can't have a negative area that gives us a -18 because it's below the x-axis. Alright, let's just check this on the calculator. So let's move this over here. So let's just do another one of these. So integral, and we're doing x squared minus 7 now, so alpha squared minus 7. Then just tap the right arrow to get to your lower limit, which is going to be -1, and tap it again to get your upper limit, which is going to be 2, and there we go, -18. So the area is just 18. Okay, on to question 5 now. Now we can, this is a sort of typical kind of question really. We can see you've got the curve, we've also got a trapezium, so I think what we're going to do is we'll work out the area of the trapezium, and then we'll integrate the curve, and we'll then subtract our two answers, and that should get us what we need. So first of all, let's have a look at the trapezium. We've got a coordinate 0 here, and we've got a coordinate 3 there, so we're going to have to plug in 0 in order to find the coordinate of A. And so A, to find A, we're going to have, well, obviously if you plug 0 into that, you're going to have, that must be at 0, 5, and for B, well, we're going to have to plug the 3 into that, so y is going to be 2 times 3 cubed minus 4 times 3 squared plus 5. That gives us 23, and so that means that B is a 3 23. So we've now got a trapezium really. So you've got a side there that's 5, a side there that's 23, and a side here that's 3. So the area of the trapezium again is just our basic GCSE formula, half a plus b, 5 plus 23 times by the height, which is 3, the height obviously being the distance between the two perpendicular lines, not the perpendicular height, and that gives us 42. So we've got that. Now we then need to find the area under that, and unfortunately we've got to fully justify our answer, so we can't just get the calculator to do it. So the area under curve, that says curve I think, that's going to be the integral from 0 to 3 of 2x cubed minus 4x squared plus 5 dx, and then we can just put it into square brackets to show I've integrated it. So that's going to increase the power of x, which is 3, by 1 to 4. 2 divided by 4 is a half, so we've got a half x to the power of 4 minus 4 over 3x cubed plus 5x. That's from 0 to 3, and then, well, because the lower limit is 0, that does help matters a lot. So when you substitute the 3 into this, we're going to get 81 over 2 for the first one, and then 108 over 3 for the second one, plus 15. Now we're just going to subtract off 0 because all of these got x in them, and that gives us 39 over 2. And so therefore our total area here is going to be the area of the trapezium, which is 42 minus the 39 over 2, and that gives us 45 over 2, or 22.5. There we go. So that's our area, our shaded area there. Okay, and question 6 now. So we've got the curve fx as gradient function, and a is a point on the curve, which is that show the equation of the tangent is here, show that p equals 3. So we've got a as a point on the curve. Let's evaluate the gradient function at that, and so f dashed of a, so just substituting a quarter into this, so that gives us 2 over the square root of a quarter minus p lots of the square root of a quarter. Now we're told, and that will work out to be 4 minus 1/2 p. That's all very good, but if we look at this, we're told the gradient at that point here is 5 over 2. So we've now got 4 minus 1/2 p is equal to 5 over 2, and we just simply solve that equation, and so we got 1.5 is equal to 1/2 p, and so 3 is equal to p. So oddly, no integration required. On to part B now. Find the equation of the curve giving your answer in the form y equals f of x. Right, so we've now got, we know our point of intersection. We can find that. So if we look, we had the equation of the tangent is this, and we know that x is equal to a quarter. So our point of intersection that must be at y is equal to 5 over 2 multiplied by the quarter plus 7 over 8, and that's going to give us, what is that, 5 over 8 plus 7 over 8, that gives us 12 over 8, which is 3 over 2. So our point of intersection is the coordinate 1/4 3 over 2. Okay, now we are told that we've got the gradient function. We're told that, and now I'm just going to turn that into a more acceptable form, and now we're going to integrate that. So using this Newton notation, with f, in Newton called calculus fluxions, by the way. Just integrating here. So similar mechanics that we've seen for this in terms of the fractions thus far. Okay, so now we've got that. So that's our general function. Problem is we've still got the plus c here. We need to find that. So we've got a point on the curve that we just worked out. So by using that general formula with a specific point on the curve, we can find a specific formula. So we're going to substitute these in here. And so we've got 3 over 2 coming in for what f of x is. It's going to be equal to 4 lots of a quarter to the power of half minus 2 lots of a quarter to the power of 3 over 2 plus c. So you just crunch all that out and you'll get c is equal to minus a quarter. So just punching that into your calculator, subtracting it from 3 over 2 will give you that. Therefore your final answer must be y is equal to 4x to the half minus 2x to the 3 over 2 minus 1 quarter. And I believe we've just got question 7 to go. Okay, so f of x is equal to this. Find the value of the positive constant k such that 1 over k f of x when it's integral, such that 1 to k and then the integral is equal to 6. Fully justify your answer. Okay, so first off we need to tidy up this. So that's going to become 8x to the minus 3 plus 3x to the minus 2. And we're going to want to integrate this, and so we're going to be going from 1 to k the integral of 8x to the minus 3 plus 3x to the minus 2 dx. So that's now going to become, we increase the power by 1, that will increase to minus 2. 8 divided by minus 2 is going to give us minus 4x to the minus 2. And then we're going to increase this power by 1, so that'll be minus 1, so that'll be minus 3x to the minus 1. And we're going from 1 to k. Alright, we're going to want to substitute in our values now, and so let's put that in some brackets. And so you've got minus 4k to the minus 2 minus 3k to the minus 1. That's the first bracket. Subtract away, and that's going to be minus 4 1 to the minus 2 minus 3 1 to the minus 1. That's going to be equal to 6 as we're told. So that means that we've now got minus 4 over k squared minus 3 over k minus, and that's going to be minus 4 minus 3, so that's going to be plus 7 is equal to 6. So let's take that off, and so if I take that off, and then I've got minus 4 over k squared minus 3 over k. You can probably hear the bin van going by. Equal to minus 1. I'm going to multiply all that by minus 1. Before I do that though, let's just make all this stuff a bit smaller. Okay, let's carry it back on now. And so we've got 4 over k squared plus 3 over k is equal to 1. We multiply. Alright, so that then allows us to multiply through by minus 1, giving us this, and then multiply through by k squared, getting me to this situation. So we can now see we're coming to a quadratic, which is k squared minus 3k minus 4 equals 0, which will then factorise nicely to give us k minus 4, k plus 1. The two possible answers, k equals 4 or k equals minus 1, but we're told k is a positive constant, so k equals 4, and that is that.